Welcome back, student. So this one is a tutorial 4.1. So hopefully you are finished. I will show the answer question 1 until question 19. So please check it. Got any problem, that means you can snap the photo and PM me. I will explain for you. So we go through to the structure question. Okay, let's see the question 20. Okay, question 20 they show about the cathode ray oscilloscope. Okay, now what is the thermionic emission means? So you need to explain for thermionic emission. Okay, remember the thermionic emission means the electron to come out when you go to hit the filament, is it? So we just write the definition for thermionic emission. Emission of the electrons from the surface of the heated metal. So you must say the electron come out from where? From the metal that's a heated. Okay, the second one, what's the function for anode A? Okay, can you see the anode A? Anode A, the function actually they want to absorb all the electron come faster, is it? So from here the function is accelerate the electron. So from the anode, cathode to anode, this one situation we find it the motion of the electron become faster, highest velocity. C, explain why the tube must be vacuum. So we know if never vacuum, that means inside got air molecule, is it? Air molecule, they will affect the electron to move it. So from here, we want to make sure the whole tube should be vacuum. That means don't have any particle that will collide with the electron. So that's why they cannot affect the deflection of the electron. Okay, the explanation is to prevent the electron from colliding with the air molecule. Okay, then we go to the question D. What will happen to the electron when the current flow through the filament is increased? That means you increase the current flow through filament. So you find it the electron how? There must more electron to come out. Okay, when your current increase. So your answer is the number of electron increases. Okay, number 2, they say the voltage of the 5 kilovolt power supply is increased. So this one we can say there's an extra high voltage. If I put the voltage increases, so what happens for the electron? So now the electron, they can come out as a cathode ray, is it? So from here your answer is, okay, electron now they move faster. Move faster means already out from the surface, and from the cathode they go to the anode and also accelerate. So this one is a situation when you put extra high tension. Okay, when I just switch out close. Okay, what means of the switch close? Refer your diagram. Diagram got one of the switch. Okay, the 5 kilovolt, they got one of the switch, is it? So from here, if I just close, what happened? So when you just close, you find it the electron accelerate already. After that, they will hit to the fluorescent, is it? Before they hit to the fluorescent, after you close the switch, I want you to see the positive and negative for the P and Q. Okay, when you just close, you find it the plate P should be positive. The plate Q should be negative. So the electron, how to deflect it? The electron must be go to find the positive charge. So they will deflect it to the P. So you see the question 3, they say the switch is closed, means the switch is on already. Okay, you close the switch, then it's on already. So we find it, the electron, they will deflect it upwards, okay, to the plate P. Okay, then we go to the question E. What happened to the energy processed by electron when they hit to the screen of the cathode ray tube? So the mean you mention the process of energy until they hit to the cathode ray tube. So when starting sure is a moving. So there's a kinetic energy from the electron. After that, they hit to the fluorescent screen, they produce a light and also heat energy. So kinetic to light and also heat energy. Okay, F, we need to do the calculation. Potential between the filament, that means the potential electrical energy. So they give you this, okay, sorry, not potential electrical energy. They just tell you the volt is how many? The volt is 9 kilovolt. Then the electron charge, 1.6 times 10 power 19. After that, they told you the mass of the electron. Okay, now the question, they want to find kinetic energy of the electron. So remember, for this topic, we just learned one formula. There's an EV, electrical potential energy, equal kinetic energy. So if the question never provide velocity, that means we cannot find by using half mv squared. So we need to create another formula. That's a EV. Okay, EV means electron, 1.6 times 10 power negative 19. Okay, after that, V is what? V is a potential difference. So the potential difference here is a 9,000. So after multiply, we get it. That's a 1.44 times 10 power of negative 15 joule. Still the joule. Okay, now they want to find is a velocity of the electron. So from here, we can create 1.44 times 10 power of negative 15 equal half mv squared. So what we need to find is a V. Remember, your final answer must be square root. So from here, half mv squared equal just now answer. Then you want to find the V. There's a 5.66 times 10 power of 7, then meter per second. So this one is the velocity of the electron. Okay, then we go to the question last. Okay, C.R.O again. Okay, come, let's see this one. A, can you name the function of the component P? P is a up and down. So up and down is a vertical plate, is it? So this one is a plate Y. Okay, what's the function? Okay, the function they want to deflect the electron up and down, is it? After that, what they form? They form the vertical beam. So this is a function for the plate Y. So we mentioned plate Y. Okay, after that, to deflect the electron beam vertically. Okay, B, the filament can be heated by AC, also DC. Why? Why we never say, oh, must AC or DC? Suppose it's nothing, because you just want to heat. Okay, I don't care DC or AC, they also can produce current to heat the filament. So from here, the answer is because the both type of the power supply, they're able to heat up the conductor. So that means we never say you choose AC or DC. Explain how the control grid control the brightness of the screen. Okay, how we control the brightness, remember? Okay, we just control the electron. When you let more electron to come out, means the brighter of the spot become increasing. If I want to make the spot become dim, don't want too brighter, so you need to reduce the electron to come out from the filament. So from here, they control the number of the electron reach to the anode. So the cathode, you want to control the brightness, you control the number of electrons on the surface of the cathode when they want to move to the anode. Okay, let's see the D. Okay, the D, they mentioned the time-based switch of the C.R.O is on. On, on means that means you can read the left and right horizontal part. Draw the waveform in the space below when the Y input of the C.R.O is connected to the dry cell. Dry cell is a directly there's a direct current. Direct current means the voltage must be constant. So from here we assume that the dry cell is a 1.5 volt. So when 1.5 volt, that means the dot must be go up 1 boxer, is it? Or 1.5. When it just go up, if I say time base is off, that should be 1 dot. Now the question, they want time base on. So how you draw? Okay, draw in a circle there. So the answer is horizontal line. Okay, one of the horizontal line. So you must show the horizontal line above the equilibrium position. Okay, now we're going to see transformer. Transformer is a generator. Okay, so transformer for generator, we must using the AC current. So AC current time based on how to draw. Okay, left and right, you can see it. So should be sinusoidal graph. Okay, so the answer like this. Okay, so this one is what I want to show for the tutorial question. I think there's nothing problem about this one. Just follow the topics, then the calculation also not more. Okay, so our lesson just until here only lah. For any problem, then you can PM me and ask about the thing. Thank you for your watching.